Hello, welcome to the course PH6B13E Computational Physics. The contents of today's lecture is taken from Core Python Programming by Wesley J. Chun. Today we will discuss topics from Module 1, Introduction to Python Programming. Python is a high-level programming language developed by a team led by Guido van Rossum in 1989. Now, before going into the details of Python, let's first understand what is a high-level language. High-level language is any programming language that enables the development of a program in a much more user-friendly manner. And high-level programming languages usually focus more on the programming logic rather than the underlying hardware aspects. So if you look at the hierarchy, high-level language is something which is in direct contact with the user. In other words, a user always writes program using high-level language. On the other hand, if you look at the bottom of the strata, the hardware or your processor is going to understand a language which is known as the machine language, and in between these two there is another language known as assembly language. Okay. Now, what are the aspects of high-level language? The syntax of high-level language consists of a set of well-defined keywords resembling ordinary English. So if you take any high-level language like C, C++, Java, or even Python, most of the keywords are English words, like you will see print, input, output, add, subtract, multiply, maximum, minimum. So all these are keywords which are very similar to English. So it's easy for you to use those keywords. And high-level languages are closer to human because, as I said, this is the language which the user directly uses. So the programming style and context are easier to learn and implement compared to the low-level languages. By low-level language, what I mean are the assembly language and machine language. Machine language is nothing but the binary language which deals with ones and zeros. So if I take a simple program of adding two numbers, if you write the code in machine language, it will be a series of ones and zeros, and you cannot literally make out anything from that. Same way, if you try to write down the program using assembly language, in assembly language, the keywords consist of combinations of three English alphabets like HLT for halt, STP for stop, MOV for move, etc. So there also you cannot get much information by looking at the code. Or if you try to program in machine language or assembly language, it's going to be much more tedious for you. On the other hand, if you use high-level language, it's going to be very user-friendly. And another advantage of high-level language is that it is independent of a computer's hardware architecture. On the other hand, assembly language and machine language, it depends on the hardware. So you need to have a good understanding about the underlying hardware before coding in any of these low-level languages. Finally, high-level languages always take less time to code and easier to read. This is something I have already said, because if you look at the keywords in assembly language or the programming language of machine language, you are not going to get much information by looking at the code. Now, if you look at this, the hierarchy, you can see that the user understands the high-level language, but if the user wants to get some computation done by the hardware or the processor, then he needs to pass on information in a language which the hardware understands, right? So high-level language is understood only by the user. The hardware doesn't understand high-level language. Hardware understands only the machine language. So if you want to pass on information, the program which you write in high-level language must be translated into machine language. And how is it done? This is done in two ways. One is by using what is known as an interpreter. So here interpreter reads the high-level program Usually the program we write in high level language like C, C++, Java, this is known as the source code. Okay. So interpreter reads the source code line by line. So it reads the first line, translates the first line into machine language, executes it, then it goes to the second line, translate the second line into machine language, executes it. So it's going to be a line by line translation, or this is going to be a sequential process. And understandably, any sequential process is going to be inherently slow. Alternatively, there is another mechanism. This is known as a compiler. Here, a compiler reads the entire program at once and translates it completely before the program starts running. So instead of going line by line, here the entire program is converted from high level language to low level language at one shot. Compiler converts the source code to an executable object code. Object code is a code which is written in machine language. So your high level programming language is converted into a machine level code now. Okay. So once it creates the object code, it stores it in a file. So in the file, the object code is permanently stored. Once a program is compiled, it can be executed any number of times without any further translation. So if you write a program in Python, first time before running the program, you need to execute it. You need to compile it. So when you compile, what happens? The compiler converts the source code into an object code and stores it in a file. Now, this object code is converted into the final output data by an executor. So first time you compile it, make the object code, then you hit run button. So when you hit run button, the executor converts the object code into output. Next time if you want to run the same program, you don't have to compile it again because the object code is already available in a file. So second time you simply press run. So only this sequence is repeated, and you can do this any number of times. Since the entire program is translated at one shot, this process is going to be much faster compared to an interpreter. Now let's try to get some general idea about programs and programming languages. First, what is a program? Program is a sequence of instructions that specifies how to perform a computation. The basic components of a program are first input. So you need to get data from somewhere to your program. So you can either feed in the data using a keyboard, or you can take data from a file or a device like an external hard disk or a pen drive. Second is output. Once you run the program creates some output data. So either you can display the data on screen, usually you use the print function, or you can send the output data to a file or an external device. Third component is math. By math, what we mean is some basic computation. So in any program, some computation will be there. So even if you are not doing any numerical program, suppose you are doing something like removing noise from a voice signal. So here basically you are performing a Fourier transform. So this is some kind of a math operation. Or if you want to remove speckles from an image, here also you are doing some kind of a Fourier transform. So behind every computation there will be some fundamental mathematical operation involved. Next is conditional execution. These are your if or else conditions. Okay. So here you check for a particular condition and execute appropriate sequence of statement. So you will check if x greater than 0, then you execute a certain set of instruction. Or if x is less than 0, you execute another set of statements, right? So you check for a particular condition, and depending on the outcome of the condition, you execute certain set of statements. And finally, repetitions. These are nothing but loops. I'm sure you all are familiar with for loop, while loop, etc. So here you perform some action repeatedly, usually with some variation. Probably this is the biggest motivation behind the invention of computers, because if one thing human beings hate the most, that is the repetition, right? So if I ask you to type one page of a passage in Microsoft Word, probably first time you will do it in 5 minutes. I ask you to do it once again, repeat the same process. Maybe now you will take 5.5 minutes. If I ask you to do it once again, maybe you will take 6 minutes because you are getting bored. And each time when you repeat the same thing, you become more and more impatient also, right? So you start making mistakes. So more you repeat, more time it is going to consume, and more is the number of errors, right? So repetition is something which human beings cannot tolerate, because they get bored basically. On the other hand, if you give it the same task to a computer can repeat it any number of times with same amount of accuracy and without making any errors. So this is the biggest motivation, one of the biggest motivations behind the invention of computers. Now, from this understanding, we can say that programming is a process of breaking a large complex task into smaller subtasks until each of the subtasks is simple enough to be performed with one of the basic instructions listed above. So any program, you can segregate it into any of these basic components. So you will know in any program you will need to input certain data, then you will do some mathematical operations, you will invariably use conditional statements, loops, etc. Finally, at the end of the program, you need to output the data, your results, right? So any complex program you can segregate into a sequence of these basic components. Now, what are the steps involved in the development of a program? First one is problem definition. Here you define the problem statement as well as the boundaries of the problem. Second, problem analysis. You determine the requirements, like what are the types of variables, whether these are integers, float, string, whatnot. Similarly, what type of function to use, whether you need to have user-defined functions or inbuilt function, etc. You also determine the bounds of the solution. For example, if you are solving a differential equation, so you will see, okay, whether you need to consider only the real solution or whether you need to consider also the imaginary or complex solution. Okay, so you define the boundaries of the solution as well. Now the third step is the algorithm development. Here you develop a step-by-step procedure to solve the problem using the specifications given in the previous two steps. Next is coding and documentation. Here you actually write the program code using appropriate programming language. Most likely you will use a high-level language like C, C++, Java, .NET, or even Python. Next step, testing and debugging. So once you write a code, usually in any of the heavy application, your code will be considerably big. It will consist of thousands and thousands of lines, and before giving it to the user, you need to test whether there are any errors. Usually in the programming language, error is known as a bug, and fixing the error is called debugging. So you need to test whether there are any bugs in your code. So usually you try different input conditions and see whether the desired output is obtained. And if you are not getting that, then you try to see where has the error been occurred and try to rectify the error. Typically, software companies, before releasing any software which is going to be used by a large number of users, they will release what is known as a beta version. So this is not a foolproof version. There will be some errors in it. So they will release it to the public, usually for free or for a subsidized rate. So the public will use it for some amount of time. Then they'll identify what are the issues with the beta version. Then they inform it to the company. So they will make appropriate changes, and after a few months, they will release the foolproof version. Okay. So releasing of a beta version is part of the testing and debugging process. And final step is maintenance. Here the program is released to the user, so user uses it. In case the user encounters any problem or the user needs some modification, then all the previous steps will be repeated. So these are some of the general aspects of programming. Let's now discuss the specifics of Python programming language. As I said earlier, Python is a high-level programming language developed by a team led by the Dutch computer scientist Guido van Rossum in 1989. In 1990, the beta version was released, and in 1991, the full-fledged version was released to the public. So, if you look at the names of typical programming languages like C, C++, Java, .NET, it's like boring names, right? So when Guido van Rossum was developing Python, so he wanted to give an interesting name to this new programming language. So that was the time he was reading some of the published scripts of a BBC comedy show known as Monty Python's Flying Circus, which was a very famous comedy show in the 1970s. So this particular name, Python, caught his attention, so he decided to keep this name for his new programming language. That's how the seemingly funny name of Python has come. In the programming world, there are two schools of thought. One school of thought says that the most important aspect of programming is the function. Okay, so when you write a program, it should be oriented around functions. So you write the entire program in terms of sub-functions and sub-functions, and using the functions, you perform all the tasks. So C is a classical example of a programming language which focus on the functional aspect of the program. So this is known as the C style of coding. There is an alternate philosophy like the one which is followed by programming languages like Java or C++. It says that the most important aspect of programming is the object or the data. So you should structure the entire program around data rather than functions. So this is known as object-oriented programming. So both are important. So luckily for us, Python combines both these features. So it has the C style of functional-oriented programming as well as the Java style of object-oriented programming. That's why in some sense you can say that Python is a much superior programming language compared to C or Java. Now, what are the salient features of Python? First, as I said, it is a high-level language. So if you look at the hierarchy, at the bottom of the pyramid, you have the machine language, which is basically binary language, consists of ones and zeros. This is the one which directly communicates with the hardware or the processor. On top of that, you have the assembly language. Then you have the traditional languages like Fortran, Pascal, C. And upgrade over that is C++ and Java because they have this object-oriented programming nature. And Python is the top of the pyramid because it combines the aspects of both C and Java. And what is the advantage of this high-level structure? Because higher-level data structures reduce the framework development time. So in Python, in addition to the traditional data structures like integer, float, etc., it has additional higher-level data structures like dictionaries, tuples, etc. Or even if you look at list, in the case of C, you have list of integers or list of float numbers, right? On the other hand, in Python, you can have a list consisting of integers, float, string, complex numbers, etc. So all this will help you to reduce your computation time or program development time. Then there are a large number of readily available building blocks which minimize the coding time and size. a lot of inbuilt functions are available. So when you write a program, you don't have to code everything from the scratch. Inbuilt or readily available functions are available. You just use them directly. So this reduces your coding time. Also your coding size also will become smaller, and these make the codes more readable. Second one, object-oriented programming, OOP. OOP is a programming model which is organized around objects rather than actions, or this is organized around data rather than logic. Historically, a program has been viewed as a logical procedure that takes some input data, processes it, and produces some output data, right? Here, the programming challenge is how to write the logic rather than how to define the data. On the other hand, object-oriented programming takes the view that what we really need to care about are the objects we want to manipulate rather than the logic required to manipulate them. So basically, you build your programming structure around your data, around your object. So you identify objects with similar characteristics, group them into classes, then you can build subclasses. So once you define a class, you can use it in other programs also. So you structure your entire program in terms of classes and subclasses. This is known as object-oriented programming. Usually when you deal with very large programs, the object-oriented programming style it performs better. The third salient feature of Python is scalability. Python provides basic building blocks on which you can build an application. So using these building blocks, one can grow the code to any size by adding new or existing Python elements. And once you build a program, you can reuse it any number of times. So basically, size is not a problem. If you want, you can write a code which consists of thousands and thousands of lines. It doesn't matter. Next is Python is extensible. So even if the size of the Python code increases drastically, it is still possible to organize it logically due to its dual structured environment. Remember, it has the C style of functional aspect and it has the Java style of object-oriented programming. So however big your program is, you can segregate into functions, subfunctions, similarly classes, subclasses, etc. So even if the code volume is really large, there is an inherent order in any Python program. And one can segregate the entire code into multiple modules and access one module's contents from the other. Next is portable. Portable means it is independent of computer's hardware architecture. This is true for any high-level programming language. So it doesn't matter whether your processor is 32-bit or 64-bit, it can work on both the processors. Similarly, Python can work on any operating system, whether it is Windows or Macintosh, DOS or Unix, it can work on any operating system. On the other hand, if you are programming in assembly language or machine language, then your program is going to depend heavily on the hardware architecture. So depending on your computer's hardware architecture, you need to tweak your low-level language programs. Next aspect, Python is easy to learn. Why? It has relatively few keywords and clearly defined syntax and simple structure. Another aspect is easy to read. Probably this is one of the biggest advantages of Python compared to the traditional high-level programming languages like C and Java. High level of readability is at the heart of the design of the Python language, following the recognized fact that a code is read much more often than it is written. So usually, if you are familiar with C or Java or C++, you will notice that there are a lot of symbols like the curly bracket, ampersand, and the semicolon, etc. And you use these symbols usually for accessing variables, a code block definition. If you are defining a function, or if you are defining a loop, you will use these kind of symbols. Similarly for pattern matching, right? So all these symbols, these are missing in Python. So how Python is able to work without using this symbol? Python uses what is known as white space indentation to denote code blocks. I can illustrate this with a simple example. Look at this program. So I have a variable I which is initialized to value 0. Then I have a while loop, and the condition is as long as I is less than 10, the loop will be executed. And inside the loop I have print hello. So basically the word hello will be printed on your screen. Then I increment my control variable by 1. So in each loop the value of I is going to be incremented by 1. And at the end of the program I print end. If you are writing this program in C, then to denote that this is a while loop, you will have to put a pair of curly brackets at the start and at the end. Similarly, at the end of each line, you will have to put a semicolon. So this is okay for such a simple program. If you have another loop inside this loop, then you have 4 number of brackets. So if you have a series of loops, you have a large number of brackets, and matching the number of brackets is a common problem in programming with C or Java, right? I'm sure you all would have faced this kind of an issue. Now in Python we don't use these brackets. Then how does Python recognize that these 2 lines are part of this while loop? Basically we use a white space here. So when you leave a white space, it indicates that the line which follows the white space is part of this loop. Similarly, here also there is a white space. This is known as white space indentation, which means that this line is part of this while loop. On the other hand, this print statement doesn't have a white space in front. Therefore, this is not inside the while loop, it is outside the while loop. So when you execute this program, the program is going to print hello 10 times all the way from I equal to 0 to I equal to 9. It prints hello 10 times, and after that it prints end. Right? So here you are demarking the code block, the while loop code block, using a white space indentation. Similarly, when you define a function, the body of the function you can demark using white space. Similarly, if you are using condition like if else, whatever comes inside the if else, you can demark using a white space. So in that way you can get rid of all the unnecessary symbols. So your code becomes easy to read, and the codes are fairly understandable even if the reader doesn't know Python much. Right? Even if you don't know Python, if you look at a code like this, you can get some idea of what is happening there. Right? So that's why we say Python is much more readable compared to the traditional high-level languages. Next aspect, easy to maintain. The software is permanent until it is replaced or become obsolete. Usually, even though the latest versions of Python are released, the old versions do not become completely obsolete. If you compare Python version 2 and 3, only there are minor changes with respect to the syntax. So even if you write a program in the old version, you can still use it with some minor changes. And it is fairly easy to maintain the Python source code. Once you save it in a file, you can store it for any number of days, and you can reuse it after a long time. And even if you lose touch with Python, it is still very easy to pick up because the syntax is fairly simple. The next aspect is robustness. Python is a robust programming language. Now, what do we mean by robustness? The robustness is nothing but the ability of a programming language to identify errors in the program. So Python helps to recognize error conditions while compiling the source code. Suppose you write a program which consists of 1000 lines. obviously there will be errors in that program. Now, if the compiler compiles this erroneous program, what will happen? The result you are going to get is going to be erroneous, right? So during the compilation, you need to identify the errors so that the user can fix the errors. Only then you get the correct output, right? So Python has an inbuilt mechanism to recognize errors. Python provides safe exits on errors, and when it exits, a complete stack trace is available. Stack trace is also known as traceback. So when the stack trace happens, it provides an indication of where and how the error has occurred. So Python tells you not only the error has happened, it tells you where did the error happen and also how did the error happen. In programming language, usually error is known as exceptions. So when Python encounters an error, it generates an exception. So once the exception is generated, a stack trace happens automatically, and the stack trace indicates the name and type of the exception that took place. I can illustrate this with the previous example. So I have the same while loop here. I am going to print hello 10 times, and at the end of the program I will print end. So here I made a mistake. So I want to print this text. So any text should be written within a pair of quotation mark. So here the quotation mark is missing. So this is a syntax error. So when I write this program and when I hit compile, what happens is it will compile the first two lines. When the compiler comes to the third line, it encounters an error. So this is an exception. Moment exception is generated, it will do a complete stack trace. So it will go through the entire code and look at the possible errors, and it is going to list out the entire error list. Okay. So this is the stack trace or traceback. So in the traceback you can see I have made mistake at the third line. So the traceback clearly tells me in line 3 there is an error. So this is the aspect of where did the error happen. So it not only tells where did the error happen, it also tells how did the error happen or what is the nature of the error. That is your last line. It told me clearly there is a name error. The name hello is not defined, and he has put the quotation mark here to indicate that the quotation is missing here. So you can know exactly what is the type of the error and where did it happen, so you can go back and fix the error. If this provision was not there, what happened? Suppose you write a program of 1000 lines and you compile it, you are not getting the desired result, and you don't know where is the error, what is the type of the error. So you have to go through each and every line one by one. So this is going to take a lot of time for you. So without the stack trace, the debugging part of program development is going to be very, very tedious. So unfortunately for us, due to Python's ability to pinpoint errors, the debugging part of the development cycle is reduced drastically. So that's why we say Python is a very, very robust programming language. That's for today. In the next class, we will discuss some more salient features of Python, and we also see what are the various ways in which we can use Python. Thank you.